These are almost identical. Numbers are the same. The signs are different, though, and that's what changes it. This one just says equal to, and this one says greater than. We always read it from left to right, even though you can read those backwards. Isn't that cool? You can read those backwards. So when I solve this one, I would add 1 to both sides, and then I would get that, and then I would divide both sides by 5, and I would get that. 2 equals x equals 2. And so how would you graph that? You just put a dot right there on the 2. That's it. That dot means that 2 is a solution. Okay? And this is just a visual representation of our solutions. So let's look over at the inequalities. It's way different, even though it looks simple or similar. So we add 1 to both sides, just like we did on the other one, and then we divide both sides by 5, just like we did on the other one. Do I have to do anything to this sign right now? Do I have to flip it or anything?
Not yet.
Actually, we don't at all right now. Do you guys know when you're supposed to flip the sign?
Yeah, when it's negative.
When it's a negative is very close to the answer I'm looking for.
Oh.
Yes?
When you divide each side by negative?
Yes, when you divide each side by negative or multiply each side by negative. When you do an inverse operation that's multiplying or dividing with a negative, then you have to flip the sign. Okay, so this says x is greater than 10. Oh, I'm sorry, that's not 10. That should be a 2. Okay, x is greater than 2. Okay, so can I put a dot on 2? Why not? Why can't I put a dot on 2? Yes, because it's greater than 2. And 2 is not greater than 2. So, we can't put a dot on 2. Can I put a dot on 3? For sure. Can I put a dot on 4? Can I put a dot on 0? No. Okay, so 4 is a solution. 3 is a solution. Those ones work. Can I put a dot on 2.5? What about 2.1? What about 2.00001? 2.000000000000001. Okay, now those would be really hard to put dots on. So because that would be so hard to put a dot on, what we do is we say it cannot equal 0, but it's everything above 0. And that's why you have the arrow. That's why you have an open circle right here. Why is that open? Because it cannot equal 2. 2 is not a solution. Does that make sense? Okay. Yeah? Yeah. If there was an equal 2 right here, then this would be a closed circle. You're right. Because then 2 would be a solution, right? So this is another visual representation of our solutions. Now there's another way to write our solutions. This is inequality form right here. That's our solution for that one. There's another way to write it, and that's called interval notation. Sorry, it's sloppy. I'm just trying to write it really fast. To do interval notation, you always put the smallest number first, comma, and then the biggest number. Now, in this case, what is our smallest number for our answer? What is the smallest number here? No, 2 is not the smallest number.
2.1.
And what? Like, that is a solution. You said 2.1, that's pretty close. 2.0000001. That's pretty small, huh? And that's part of the solution. But can 2.000000000000001 be part of the solution? Now, do you really want to write all that? No. And so we don't write that. Instead, what we do is we write 2, just like what you guys said before, but we say it's not part of the solution. You know how we say it's not part of the solution? We put a parenthesis next to it. Parenthesis says it's not part of the solution, but that's the starting point. Then I put comma. Now I got to put the biggest number. Now this one doesn't have a stopping point. It has an arrow right here. So what am I going to put there? Infinity. And so I put an infinity sign right there. And then you put a parenthesis around the infinity sign because you can never include the infinity sign in your solution because an infinity sign is not a number. It's an idea. It's a concept. And so we always put a parenthesis around it. So that, my students, is interval notation. Doesn't it look like coordinates? It does. Don't confuse it though. Now there are times when we need brackets. And I'm going to show you guys when we need brackets just after I answer that question. Surfer Girl had a good question. Just want to make sure I repeat it so everybody knows it. If you have an infinity sign on the on the lower side or the bigger side, then you know that it's unbounded. If there's an arrow, if you were to graph it and there's an arrow, then it's unbounded. But there are other cases when it is bounded. Let me show you. Boom. Here's a case where it's bounded. Now, you guys are really familiar with inequalities, and so I was going to start with that one. Here's your inequality. Let's graph it. Yes, that's right. So we have -4. It cannot equal -4. It can equal 3 because of the equal to sign right there. And it says x is greater than -4. You see, I read it backwards. This is a less than sign, but because I'm reading it x and to the left, it says x is greater than -4. So I got to point an arrow to the right. And then the 3 part, it says x is less than or equal to 3. And so I'm going to take that 3 and point an arrow to the left, because that's where all the lesser numbers are. So all my solutions are between these two right here. Now you don't have to do the shading part. I'm happy with the arrows. But this one's bounded, because there's two numbers that it's contained by. Over here for interval notation, the graph is pretty much the same, except instead of using an open circle and a closed circle, I'm going to use a parenthesis and a bracket. Brackets are the same as closed circles. It says that number is included. So 3 is included in the solution. You guys, does that make sense to you guys? Yes? Okay. So now let's write it. Let's write what interval notation is. Interval notation is, the lowest number is 4. What's the biggest number? 3. Parenthesis or bracket around the -4? Parenthesis. Bracket or parenthesis around the 3?
Bracket.
Done. That's interval notation. Let's look at the next one. Now the next one, we got to change this because that number is too big. Let's see. I guess I wasn't thinking when I did this. We're going to make this one a -3. And we're going to make this a 2. Let's make it a +2. That's pretty. Okay, so let's graph this. I'll probably graph this. For this one, I start at -3, and it's a closed circle because it says equal to. This line right here says equal to. And then it says x is less than 3, so I'm going to point to all the numbers less than 3. The other one says x is greater than +2. There's no equal to, so that means I have to have an open circle, and I point the arrow to the right. Now this time the arrows are pointing opposite directions. They are not pointing towards each other, and they're not even pointing in the same direction. Now, if they're pointing in the same direction, that gets a little tricky, and I can help you guys out with that, but most of you guys can figure it out if you think about it. But let's look over here at interval notation. So I'm going to do my graph so it resembles interval notation. So I'm going to put a bracket right here on the -3 and point the arrow that way. And I'm going to put a parenthesis right here on the 2 and point it that way. See, we have two different intervals here. Whenever you see the arrow, you know that it's unbounded, and you have to put an infinity sign there. So let's do this one first. That one, what's the smallest number in this interval? That's right, -infinity. What's the biggest number?
3.
-3. Okay, bracket or parenthesis around -infinity? No, never bracket. That's always parenthesis around infinity. Bracket or parenthesis around -3? Oh, it says right here. It's bracket. Okay, and then we go over to this one right here. We have the smallest number being 2, and what's the biggest number? Infinity. It's unbounded. It has an arrow. Okay, so we put a parenthesis around the infinity sign. Around the 2, we also put a parenthesis. Now, this is not two solutions. It looks like it. You have to put a U right here, a union. Union means or. Union or. This is the answer. No, you must write union for interval notation. What you're saying is both of these make my solution. If it satisfies one of these intervals, then you know that it is a solution. When I say it, I'm talking about the... All right, you guys want me to solve this? No. Hey, if you guys already know how to do it, don't write it down, okay? Add 1, add 1, add 1. I'm getting rid of this 1 right here. So peace out, and I have less than 4. There's 6x because the 1's gone, greater than or equal to -2. I don't like splitting it up because this way I can write less. Now, how do I get rid of that 6? I divide it by 6. So I divide everything by 6, and so now I have, peace out 6, new now equal 1. 1x greater than or equal to. This is negative 1 over 3, and when I simplify that one, I get 2 over 3. So there's my solution, but that's in inequality form. Let's write it in interval notation. Now, for some, when you're first starting writing the interval notation, it's easier to write interval notation if you have your graph. And so I'll put negative 1/3 right here, beautiful 3, and 2/3 right here. Okay, so for this one, it's a bracket. And for this one, this one right here, that's a parenthesis. And this says x is greater than this guy. And so I can, I'm just double checking it. I shade this way. And it says x is less than that guy, and so I can shade less than that guy. And so there's my interval. I just have to write negative 1/3, put a bracket around it, parenthesis 2 over 3, and put a parenthesis around that guy. That's your final answer.